Section 5 is the law of sines. So for any triangle ABC, let the lengths of the sides opposite angles A, B, and C be A, B, and C respectively. So basically the side across from angle A is going to be side A. The side across from angle B is going to be side B, and so on. The law of sines relates the sine of each angle to the length of the opposite side. So sine of A over A is in proportion with sine of B over B, which is in proportion with sine of C over C. Now here's why it works. If you draw the altitude from C to AB and we label it H, ACD and BCD are right triangles. Well, the sine of angle A would be H over B. The sine of angle B would be H over A. If we multiply both sides by B here and by A here by the multiplication property of equality, we get that B times the sine of angle A equals H, and A times the sine of angle B equals H. Since they both equal H by the transitive property of equality, we can say they equal each other. And then if we divide both sides by A and we divide both sides by B, we get that the sine of A over A equals the sine of B over B. So this is a law that's going to help us to solve some problems. So the law of sines, if you have two angles and a side, this is not like you're proving anything congruent. You just have two angles and a side. In triangle ABC, the measure of angle A is 48 degrees, which is marked here, and the measure of angle B is 93 degrees. Side AC is 15 units. They want to know to the nearest tenth what is the length of BC, so we're looking for this side. We set up a proportion because if we're looking at angle A, the sine of angle A over side A, which would be the side opposite it, so this is our A, has to equal the sine of angle B over side B. Well, the sine of 48 degrees over A, which we don't know, would have to equal the sine of 93 degrees over side B, which is 15. So that's where we get this proportion from. When we cross multiply, we get sine of 93 degrees times the length of BC equals sine of 48 degrees times 15. To get BC by itself, we divide both sides by the sine of 93 degrees. We plug all of this into our calculator. We get that BC is approximately 11.16 and so on, but it asks for our answer to the nearest tenth. So BC is approximately 11.2 units long. Now the other way that you can use the law of sines is if you have two sides and one angle. So we're told that RT is 11 units, ST is 18 units, and the measure of angle R is 120 degrees. So the first step is to draw and label the diagram if you didn't already have the diagram. Well, this angle has this side across from it, and this side has this angle across from it. So we know that the sine of 120 over 18 has to equal the sine of whatever angle S is over 11. Now we're trying to find the measure of angle S. So when we cross multiply, we get 11 times the sine of 120 degrees equals 18 times the sine of S. We want to divide both sides by 18 here, so that's where we get this step. But then we can't take the sine of a variable, so this is where the inverse sine comes in. So we do the inverse sine of both sides, and make sure when you plug this in, it's in parentheses, so that you take the sine on the inside and the inverse sine of the final answer. you get approximately 31.9539, and that means that the measure of the angle to the nearest tenth is approximately 32.0 degrees, and you have to have that 0 because it's said to the nearest tenth. Section 6 is the law of cosines. So for any triangle ABC, the law of cosines relates the cosine of each angle to the side lengths of the triangle. So a squared equals b squared plus c squared minus 2bc cosine of a. It's a long formula, but you need to memorize them. B squared equals a squared plus c squared minus 2 times a times c times the cosine of b. So basically, if it's a squared equals b squared plus c squared minus that b and c are being multiplied here, and it's the cosine of whatever letter is out here. So c squared equals the other two sides minus 2 times those two sides, cosine of this angle across from this side. So here's why it works. Note that b squared equals h squared plus x squared. So b squared equals h squared plus x squared. Makes sense because it's a right triangle. And x, this side length, equals b times the cosine of angle A. Because if we're looking for angle A, cosine of A is going to equal the adjacent over the hypotenuse. The adjacent is x, the hypotenuse is b. We multiply both sides by b, and that's where we get this from. So using the Pythagorean theorem with triangle BCD, you'd get a squared equals c minus x, which you see here, because c is this whole side. So c minus x is going to be just this piece, squared plus h squared. So a squared, the hypotenuse, equals c minus x squared plus h squared. When we simplify that, we get c squared minus 2cx plus x squared, so that's just from using FOIL, plus h squared. We know that 2cx plus x squared can be replaced by 2cb cosine of a plus b squared. And that's because instead of b, we're substituting b squared for the x squared plus h squared. So that's where the b squared is coming from. And we're substituting b cosine of a for x because that's what we had up here. So b cosine of a is being substituted for x, but that still leaves the 2c. So that's where we're getting this formula from, but it always works. So let's do some examples so it will make more sense. So the law of cosines, where you have two sides and an angle that's given. So you know that side AB is opposite angle C. So AB equals C, which equals 10, because if this is angle C, then this is going to be side C. We know that BC is opposite angle A. So that means that A is 22. Now the measure of angle B is 44 degrees. We need to know the length of AC, that's B. Because we know the measure of angle B, and we need side B, we're going to substitute the angle measure and the two side lengths into this formula and solve for B. So because we need B, we're going to substitute it into this formula. So this is our law of cosines. We're going to plug in a squared. We know that a is 22. C squared, we know that c is 10. Then 2 times a times c, and then the cosine of angle B. Now we're using this one because we have angle B and we're looking for the side opposite it. You plug all of this into your calculator and you get that b is approximately 16.3551364. Remember, you have to take the square root of both sides once you simplify the right-hand side, which means to the nearest tenth, b is approximately 16.4 units long. The other way you can use the law of cosines is if you have three sides. So we need to draw and label the diagram because this type of question takes more time than the law of sines did. So we have our three sides. We're going to use the law of cosines to set up an equation. We're looking for the measure of angle V, and we have the side across from it. That means we're going to set it up as TU squared, so the side across from the missing angle squared, equals the other two sides squared minus 2 times the other two sides cosine of the angle that we're missing. And then we plug in all of that information, but notice here we're finding the cosine of a variable, so we're going to have to do the inverse cosine function. So we're solving for the measure of angle V, which means we're going to combine these like terms and subtract them to the other side, and then we're going to divide both sides by negative 95.14. So we get cosine of V equals this. We're going to take the inverse cosine of both sides so that we get V by itself, and when we plug all of this into the calculator, we get that the measure of angle V is approximately this number. It asks to the nearest tenth, so we round it and get 37.0 degrees. And make sure that you have that 0.0 because it said to the nearest tenth, even though there's no number there other than 0. We are going to do a lot more practice when you get back with law of sines and law of cosines, but make sure you go through all of the steps on the calculator and you start memorizing those formulas because you will need to have them memorized.